Let's delete our previous work and start a new network so we can actually get this mullet going. Let's select the growth geo and create a Yeti node by creating from selected mesh. This should add the mesh shape to the Yeti node's object inputs. Next, we'll create a Yeti groom node. And as we create these nodes, we should name them so that we can easily identify them in the Maya scene. So we'll name the Yeti node Kurt Mullet. And the groom node, we'll name it base GRM for groom. Next, we'll add the groom to the Yeti node graph. Now we can build a Yeti network. So in the Yeti graph editor, select the Yeti node and create an import node. From the input objects list, select the head geo shape. The import node defaults to geometry, so we don't have to change the type. And let's give this node a name, head growth geo. Now another import node, name it base groom. Change the type to groom, and from the input objects list, select base groom. Now what we need is a scatter node, a grow node, and a comb node. Let's connect the base groom to the comb node and to the grow node. Now let's leave the default naming for now. So far we have scatter points on the entire mesh. We can define the growth area with a selection set, or we can use paint maps. So we'll try paint maps this time, starting with a shader, even though it isn't needed for it to work in the Yeti network, but it is helpful just to see what we're working with. So let's point the file node to the base density maps and switch the UV tiling to Mari, generate and apply the shader so that we can see the area that the base groom will cover. Now let's go into the Yeti graph editor and build a texture into our network. Let's create a texture node, open it up, navigate to our maps, select density maps. Here we go. In the attribute input, let's enter density as we want the texture node to drive the groom's density. And lastly, we have the UNV coordinates. If we refer to the Yeti documentation, one thing to note is that Maya inverts the V coordinates. So we'll have to invert the V input by adding a negative $T. But since we are using UDA maps, we need to use a different expression. So let's copy and paste this expression into the V coordinate input. Now let's name this texture node base density texture. The expression language that Yeti is compatible with is SCEXPR, which is an open source language. You can familiarize yourself with this language through their site and by searching across the internet. Now let's go ahead and feed the geometry input node into the texture node and plug the texture node into the scatter node. Now let's make the scatter node active, and we are still seeing scatter points being populated on the entire geometry. The reason being that we are feeding a texture node into the scatter node, but we haven't specified the texture attribute. So let's go ahead and enter density, and we're almost done. One thing that I missed is actually adding the UDIM global variable to the file input so that it'll read multiple tiles as one. So let's remove the number padding and enter UDIM, and there we go. Now we can see that the scatter points are being generated within the defined density map area. Now we can actually start laying down some strands.